The Leaning Tower of Pisa, a freestanding bell tower in the Italian city of Pisa, is a world-renowned landmark. Its construction began in the year 1173. The builders completed the first few floors on a shallow 3-meter foundation. The ground underneath, however, was not strong enough to support the weight. It was a soft mixture of sand and clay, which proved to be an unstable base for such a heavy marble structure. As the builders added more weight, the foundation began to sink unevenly. This soft subsoil compressed more on the south side, causing the tower to tilt. The lean was noticeable even before the third story was finished. The initial construction halted for almost a century, partly due to the unstable ground and partly due to military conflicts. This long pause was unexpectedly beneficial. It allowed the soil beneath the tower to settle and compact, which likely prevented an early collapse. When construction resumed, engineers attempted to compensate for the existing tilt. They made the new floors taller on the shorter sinking side and shorter on the taller rising side. This corrective action gave the tower its slight banana-like curve, but it did not solve the fundamental problem. The additional weight of the new floors only made the foundation sink further, and the lean continued to worsen over the centuries. For hundreds of years, the tower stood as a beautiful, albeit flawed, monument. Its precarious tilt became its most famous feature, attracting visitors and artists from all over the globe. However, gravity is a relentless force. The lean was not just a charming quirk, it was a sign of structural distress. By the 20th century, the tilt had increased to a dangerous degree, reaching over 5 degrees from the vertical. Engineers and preservationists grew increasingly concerned. The constant stress on the masonry was causing microfractures, and the risk of a sudden, catastrophic collapse became a very real possibility. The tower was a symbol of Italy, and its potential loss was unthinkable. The growing danger prompted serious action. In 1990, the Italian government closed the tower to the public as a precaution and assembled a commission of international experts. Their mission was clear but incredibly complex: to stabilize the tower and ensure its long-term survival without ruining its iconic lean. They needed a solution that would reduce the tilt enough to make it safe, but not eliminate it entirely. The commission of experts began their work by studying the tower and the ground beneath it with unprecedented detail. They used advanced sensors, computer models, historical data to understand every aspect of the tower's behavior. They needed to know precisely how the structure responded to changes in temperature, rainfall, and ground stability. Over the centuries, many ideas had been proposed, and some had even been tried with disastrous results. One 19th century attempt involved digging a walkway around the base, which removed supporting soil and caused the tower to lurch suddenly. The new team knew any misstep could be the final one, so they proceeded with extreme caution. As a preliminary safety measure, the engineers installed a temporary counterweight system. They placed 600 tons of lead ingots on the north side of the tower's base, opposite the lean. The immense weight acted as a brace, pushing down on the higher side of the foundation. The goal was to reduce stress on the leaning south side and provide a safety margin against further tilting. While not a permanent fix, it was a crucial first step that stabilized the tower. Another safety measure involved anchoring the tower from the north. The team attached strong steel cables to the tower's third story. Those cables connected to massive A-frames and were anchored deep into the ground. This system acted like a harness, ready to hold the tower if any work caused sudden movement. The safety net built confidence and allowed delicate underground work to proceed. It was a fail-safe to protect structure and workers before the main phase began. With safeguards in place, the team could focus on the core problem: weak soil under the south side. They needed a method to gently and controllably encourage the tower to tilt back north. The central idea was revolutionary in its simplicity. Instead of pushing the tower up or adding permanent supports, the plan was to remove small, controlled amounts of soil from beneath the north side. By creating small voids on the higher side, the tower's own weight would settle into them, rotating it back toward a more vertical, safer position. The heart of the stabilization project was a technique known as soil extraction. This method involved a specially designed drill similar to an Archimedes screw encased within a rotating tube. The engineers drilled a series of diagonal holes into the ground under the north side of the foundation. The outer casing of the drill prevented the surrounding soil from collapsing into the hole as it was being created. Once the drill was in position, the internal screw would be activated carefully, drawing out a small volume of clay sand. The process was incredibly gradual and precise, allowing for micro-adjustments. This delicate operation began in 1999. The team removed soil from 41 different locations, working slowly and methodically. Each extraction removed only a few liters of earth at a time. The tower's response was monitored in real time with a vast network of sensors. If the tower began to move too quickly or in an unexpected way, the work would immediately stop. This feedback loop between action and observation was critical to the success of the project. The tower, which had been leaning southward for centuries, began to slowly, almost imperceptibly, rotate back toward the north. The process can be visualized as working with a large, unbaked clay terracotta sculpture resting on a soft pad. Imagine the sculpture is tilting precariously to one side. To straighten it, you would not push on its top, as that might break it. Instead, you would gently scoop out tiny bits of the soft pad from under the high side. With each small scoop, the sculpture's weight would cause it to settle, slowly rotating back toward the center. This is exactly what the engineers did, but on a massive scale and with a priceless historical artifact. The slow, patient removal of soil was the key to correcting the lean without applying any dangerous external force to the tower itself. By the time the soil extraction was completed in 2001, the results were remarkable. The tower had been guided back northward by about 45 centimeters, 18 inches, as measured from its top. This reduced its lean from approximately 5.5 degrees to about 5 degrees, returning it to the tilt it had in the early 1800s. While the counterweights and cables were removed, the engineering team also performed necessary repairs on the tower's masonry, fixing cracks that had developed over years of stress. The project was officially declared a success. The tower was secure. The successful stabilization of the Leaning Tower of Pisa stands as a landmark achievement in the field of engineering and cultural preservation. The final result was a tower that was significantly safer but still visibly leaning. The goal was never to make it perfectly straight. The lean is an inseparable part of its history and identity. The project reduced the immediate danger of collapse and halted the progressive increase of the tilt. Experts now predict that the tower will remain stable for at least the next 300 years, requiring only minor monitoring and maintenance. In 2001, after more than a decade of being closed, the tower was reopened to the public. Visitors could once again climb its spiral staircase to the top, confident in the structure's newfound stability. The project demonstrated how modern science and technology can be used to save ancient treasures. The engineers did not use brute force. They used a deep understanding of physics, geology, materials, science. Their solution was elegant because it worked with the tower's own properties, using its immense weight as the force for its own correction. It was a quiet, almost invisible intervention that produced a profound and lasting effect. The story of the tower's rescue is a powerful lesson in problem solving. It shows the importance of caution, patience, and meticulous planning when dealing with irreplaceable heritage. Just like an artist restoring a fragile clay terracotta masterpiece, the engineers had to be sensitive to the material they were working with. They couldn't simply impose a modern solution onto an ancient structure. Instead, they had to listen to the tower, understand its weaknesses, and develop a solution that was as gentle as it was effective. The project was as much an art as it was a science, balancing technical requirements with aesthetic and historical reverence. Today, the Leaning Tower of Pisa continues to stand as a testament to both the flaws of its original builders and the genius of its modern saviors. It still leans, reminding the world of its long and dramatic story. But now, its lean is no longer a symbol of imminent danger. It is a feature that has been secured and preserved through human ingenuity. The tower is safe, its story continues, and it remains a source of wonder and inspiration. The careful, almost surgical work of the engineers ensured that this iconic structure did not fall into ruin,